Okay, so let's get started. So today we're going to be covering using LTSPICE of a Mac. And LTSPICE of a Mac definitely brings on some new challenges, but let's go through a few steps. So first, as you can see here, going into the tools setting, and what I'm going to do is I like to configure things to make it my own. So you can actually vary the color. So I'm varying the color as we speak. And as you can see here, you have options between the wire or the background. I think by default, the wire colors are blue, the background is gray. But I prefer a background that's actually white because it's just my preference, and hopefully you might appreciate that one too. Plus it makes it easier, so if you're gonna copy and paste a few of your circuit diagrams, you can certainly cut and paste it back into a Word document with a nice white background, as opposed to the gray that doesn't usually work for anything. But again, you can choose almost any color your heart desires by adjusting the RGB settings. Okay, so now that I have it the way I like it as far as the background is concerned, with the Mac is distinctly different than the PC. I'll make a video about the PC, but essentially when you go into this, what you would like to look for is that you have the view, you have the edit, draft, draw, and so in order to get to this file menu, you have to right click with your mouse, and then right clicking of your mouse brings you to this setting. So once in this setting, you can go ahead and select on a component, and for now we're just going to build a quick series circuit. Go over a series circuit in other videos, so please take a look at that. I'm going to attach here just one voltage source. To get out of that voltage source, you hit the escape key, so you just click on your component. Of course, there's also shortcut keys as well. That's the function keys above. So F1 through F9, you have a bunch of options too, which is pretty great. And as you can see here, it says click on Control R to rotate any of your components. So I'm going to put down 3 resistors, hitting Control R to rotate through them. I'm arranging the series circuit into a nice, hopefully comfortable pattern that I can work with. As you can see, once you have the arrangement, we're going to have a series circuit with 3 resistors and 1 source. You hit escape to break out of it. And now when you go to the draft tool, I could either hit so again, if I want to add an additional component, I certainly can. Hit escape to break out of it. So if I want to include the wire by default looks like it's F3, or you go ahead and click it, right click to get into that setting. You go from the end of each component, then you bring it over to each resistor. And the same again, you go from any end of a resistor back over. It takes a little bit to get comfortable with it. And as you go through this, it gets a little bit easier and hopefully faster over time. Certainly once you do this, sometimes the grid might make it a little bit easier to put the grid setting on. I prefer my grid setting off. Again, that's because I love to copy and paste a lot of these files or schematics or drawings that I'm working on into some other file. All right, so once you have your wires set, you can do a couple of other things. What I like to do is go over to this net name and give it a ground. So without having a ground with any simulation of circuits, I guess most of them actually won't work. So I'm attaching a ground to the closest I can to the negative terminal of my voltage source, so that way I have that universal ground component there. And as you can see, I'm going to right click on each of my components to assign it a value. You can also see on top there, it says right click to edit R, the value of R1. As you can see there, it says enter a name value for new value for R1. So make sure you're clear that there's actually values for your resistors, values for your voltage, but you can also change the name of it, R1, to any other variable you would like. You can call it literally resistor 1 if you wanted to. But if you do try to run this and something goes wrong, it's more than likely that you didn't change the numeric value, you changed the header name of the resistor. So keep in mind that when you're clicking on it, that there are 2 options for each component. There's a value and there's also the component's name. So make sure you're hovering over the component and right clicking it in order to change that name. All right, so in order to run the analysis, you can go ahead and click and run, and you notice nothing actually happened, which something's missing. So in order to have this to work, you have to go ahead and click on the SPICE directive. And the idea of this is to actually do a runtime. And the runtime for this, it doesn't matter what you use. Out of default, like use 1,000. And what that basically says that you're having your simulation run for 1,000 seconds. Okay. So now that I have that, I'm going to try to put both of my schematics. I could actually see the results, kind of like an oscilloscope type setting. Well, now I can look at voltages and currents of all of my components. So if I hover my mouse over each part, that actually is a current meter that you're seeing now. Now, if I hover outside of my components, you'll notice that it goes from red. So that's actually our prongs that we use for our voltmeters, right? And it will then tell you the voltages that are associated with it. So if I want to know my voltage source, I hover from the, and I left click, hold down, drag over, it's going to tell me the voltage of each component. So the first voltage of the component was 20 volts. And then you have to do it twice to see only that component. But do it a second time, I'll see that my first component R1 is 6 volts. And now if I do that again, I drag my mouse from the red, so it's like a red and black of my voltmeter, you can imagine. You'll see on the bottom that it says the voltage of 4 volts, right? It's showing both the 6 on the top. It says node 1, and also says N002. So the top one is the 6 volts. The lower one is the 4 volts. But if I only want to see the voltage of R2, right, I have to do that drag and drop scenario one more time so I could actually see the actual voltage of R2. All right, so keep that in mind. It's also clicking a couple of things to show you that you could also vary the colors too, if that helps you to see this as well. So here we are, we're going to try R3 again, and you can see all 3 of our voltages now. So you can see that you have the 6 volts, the 4 volts, and the 10 volts all showing all at once. If I want to look at R3 exclusively, then I do it one more time. You notice that it's now going to show only the 10 volts, hence the voltage of N003. Now, if I hover my mouse and you see the current probe sticks out, now I can measure the current of each of my components. As you can tell, the current value, I'm going to show you the screen again, it's not changing. And the reason it's not changing because current is the same everywhere for a series circuit. So as you go through this and you click on it, you'll notice that it just stays the same value of 2 amps. So I have 2 amps everywhere. Okay, so it's pretty important when you're working on this stuff is to distinguish the two. You could also add comments to your circuit schematic, and so you could literally write down the voltage of each. You can write down the voltage of R1, voltage of R2, voltage of R3. Again, that's kind of helpful. So if you're working on a paper or a project or a lab and you want to literally put down your results right on there, you certainly can. And you can put that values right onto the schematic, and I like to do that from time to time, especially if it's something I plan to cover, or I may not look at it for a couple of weeks or months. I would certainly like to have and remind myself what the actual solutions are, or else I have to end up recomputing everything, which is time consuming. All right, so as you notice there, it's easiest going ahead and looking at the comments, putting a new line in for each one. And you'll notice that comments are in blue. Anything that's part of the SPICE directive will end up being black font. So if you notice you make a mistake, you could always go back and change it. And as you can see and notice here, I accidentally put here SPICE directive. So if I leave it in that setting for R3 as 6 volts, it's not going to be showing as the color of the highlight, and it's actually trying to include that value to our SPICE directive. So there's black, so that means I didn't mean to do that, so I'll go back and fix that as I'm putting this together. But you could always edit later, which is great. Okay, so again, go ahead and again notice what I'm doing with the comments in each section. And in addition to that, including the current solution values, we remind myself that it's going to be 2 amps, again, for an entire series circuit. And here's where you notice I switch it from a SPICE directive to a comment for the voltage of R3, and that's one way to do it. So if you're trying to move things around, you can by just dragging with your holding down the left click and dragging it over. What I actually like to do is actually hit the space bar. The space bar actually aligns all of your schematic and solutions all directly into the center of your screen, and it makes it a little bit easier. It's easier to find, and again, clicking on the quick space bar is nice and easy and helpful to do that. One last thing that we can do is that we can look at all of our nodes and our values that we entered in for each of our components by going to view and looking at our SPICE netlist. Okay, so when you do that, it's going to pop up a new window, and you can see that it lists there each node and each of our values that are used for each of the resistors and the voltage sources, as you can see there as well. So I'm highlighting, for example, the 3 ohms, the 2 ohms, and the 5 ohm resistor, and the 20 voltage source. Okay, and you also see the comments in green that I included, and the time that I use for this file to run. So it's actually really helpful as well. And I kind of find that, you know, as you go a little more advanced with this, you may need to edit that or use that in the back end, but it's usually quite interesting and fun. All right, hope you learned something. Okay, so this time we're going to cover parallel circuits with LTSPICE, and again, continuing from what we learned from the series circuit of LTSPICE, we're going to go ahead and look for our components, going through our modes. We're going to go to draft or hitting F2 to component screen. I just use 2 components for now, voltage source and resistors. Later on, I'll cover capacitors and inductors as well, both in DC and AC. So I'll go over everything as much as I can, and hopefully get you a great feel on how powerful a tool like this is. And again, for now, LTSPICE is free, and it's possibly one of the best free softwares in the electrical world to get your hands on, which I really appreciate the efforts from the company putting this stuff together. Okay, so now that what I'm going to do, I'm going to repeat the problem we did earlier with the series circuit. We're going to use the same exact resistors and the same exact voltage as we did before. It's again the 20 volt source, and again, instead of being in series, we're going to use a different configuration, which should be in parallel. It doesn't really matter which order you connect things. I'm just showing you that I'm going from the external R3 this time, and I'll jump around so you can get a feel for how to connect it. It does take a little bit of adjustment to getting used to where to click on the components and when they're actually attaching to an actual wire or line, but once you get the hang of it, it's not so bad. So as you can see here, it makes that blue dot once it's definitely attached to the external wire, which is pretty neat. Okay, so as you can notice, I hover my mouse over the resistor 1. You'll notice the words underneath the word entitled on the top toolbar. I also right click to edit R1, right? And that's when you actually enter in, you know, a resistor value where you see the units of ohms there, which is really important. So I'm using the same values used before, which is 3 ohms, 2 ohms, and 5 ohms in parallel. I'm going to use 20 volts this time. And if you're new to circuits, hopefully, or you have a little bit of background, you should hopefully realize that anytime you have resistors that are in parallel with each other, they all just share the same voltages. So if we have 20 volts as our source, hopefully we're going to read 20 volts across each of the resistors. So their voltages may be the same. Don't forget to include your ground, as you notice here. And as you notice, as I have my mouse there, at least I did a moment ago, there's only 2 nodes. There's a top node and then the bottom node. The bottom node can be called a ground node or a reference node. And notice if you hit run immediately without including the SPICE directive, then it's not going to actually output anything. So don't forget to do 1,000 seconds. It doesn't have to be 1,000 seconds, but just convention to use that amount of time. And now you can do that. You can run your circuit and now do the measurements for voltage and current. As stating before, you expect the voltage to be the same. What should be different is the currents across each of the resistors. And the net, based on Kirchoff's current law, the sum of all the currents entering either the top node or the bottom node should be equals to 0. All right, so now we're just confirming that the voltages are all the same. And you notice on the scale on our plot, it shows that Vn001, which means the voltage of node 001. Let me just adjust the screen a little bit so you can see everything side by side to make it a little bit easier to visualize or to see the results. And as we do that, again, I hit spacebar within our image so that we can actually put an entire schematic in frame. And now I hover my mouse across each of the resistors and the voltage source, and you'll see that there's different current values. So if I click on R2, it's 10 amps. If I click on R3, it's 4 amps. If I click on the source, it's about, what is that, 20.664 or 6 is the current that's leaving or driving through the voltage source. And if you don't know how to compute that, I'll make a separate video on how to compute that as well, so you'll have an idea on how to do that. And you can also plot all three of them on the same plot as well. So if you click each of them consecutively, you'll see the answers here of the 10. Those at about approximately 6.8 and approximately 4 amps, right? And if you click on the current source twice in a row for either R1, R2, or R3, it'll only show the current value for that particular resistor that you're selecting. So you have options, which is kind of nice with the software. And again, you can see here what the voltages are and the resistors that I've used. And you notice this is N001, which states that they're all attached to the same node, which is really helpful once you get the hang of this. All right. And again, from the plot itself, you can actually go there and make some changes to, things like the background, a lot more other types of options, which I'll go over the options as they're needed, and we'll continue to expand our knowledge within this area. So hopefully you've learned something and you're getting a little more comfortable with how to use LTSPICE. And as we go through this, I'll do comparisons with other